In this video, I will demonstrate how to calculate acceleration using algebra. So we know that by definition, acceleration is the change in velocity over the change in time. And whenever we see a change in quantity, like a delta v, then we know that this is the final quantity. So in this case, the final velocity minus the initial velocity. Okay. Now I will do a simple example just to illustrate the idea how you can do these calculations. Okay, but this is the theory. This is the theory that we need. Let's say that we have an initial velocity, so we have our v initial is equal to. I'm just gonna choose simple numbers, so this will be 1, 2, and 3. These are in meters per second. This is my initial velocity. I have a final velocity that is, again, I'm choosing simple numbers, 4, 5, and 6. And this is in the same units. Okay. And I have a time interval delta t of 0.2 seconds. Now I need to find the acceleration for this time interval. I need to find the change in velocity. So I need to use these two vectors to find delta v. And this will be my v final minus v initial. Now to calculate this difference, I need to subtract the x component. So I will need to do 4 minus 1. And for the y components, I need to do a 5 minus 2. For the z component, I have to do 6 minus 3. So if we do this calculation, we will find the delta v to be all x, y, z components will end up being the same, 3.0, because their differences are the same. So this is a delta v of 3 meters per second. Now to find the acceleration, I need to plug in the vector of delta v here and delta t. So this will be my delta v. This is my delta v vector, and this is my delta t. We have 3, 3, and 3 for the z component, and we need to divide those with the 0.2, and this will give us as a result 15 and 15 for all x, y, z components, and now the units are meters per second squared. So this is a simple example of how you can use algebra to, if you have the two velocities, the initial and the final, and your time interval, to get an estimate for your acceleration. Now, if this delta t is a time interval much smaller than the phenomenon you're studying, this would be an estimation for the instantaneous acceleration. If this delta t is the same order of magnitude as the phenomenon you're studying, then you're really looking at an average acceleration. So just keep that distinction in mind.